If you could step outside right now and look up at the night sky, you'd see roughly the same stars ancient humans saw tens of thousands of years ago. The constellations haven't moved enough to matter, but everything below that sky, the land, the animals, the climate, the coastlines, everything down here looked completely different. Not slightly different, unrecognizably different. The world that early Homo sapiens walked through was colder, wilder, and in some places almost impossible to imagine if you're picturing anything like the world we live in today. Forests where cities now stand, ice where rivers now run, coastlines that have since drowned under hundreds of feet of ocean, and animals that make modern wildlife look tame by comparison. So what did it actually look like? What was Earth doing during the stretch of time when our species was first figuring out how to survive on it? The answer depends heavily on when you're looking, because the planet wasn't sitting still. It was shifting constantly, and the humans living through those shifts had to keep up or disappear. Most of this story takes place during a period called the Pleistocene, which ran from about 2.6 million years ago up until roughly 11,700 years ago. That's a long window. What happened inside it shaped everything about who we are and where we ended up. Let's start with the ice. For most of the Pleistocene, Earth cycled in and out of ice ages on a rhythm tied to small wobbles in its orbit around the sun. These weren't short cold snaps. Each glacial period lasted tens of thousands of years, long enough that dozens of generations of humans were born and died without ever seeing what the land looked like during a warmer phase. At the peak of the last glacial maximum, around 20,000 years ago, ice sheets covered roughly a third of the planet's land surface. The Laurentide ice sheet sat over North America like a slab of frozen rock 2 miles thick in places. Scandinavia was buried. Most of Britain was under ice. The Alps were swallowed. And it wasn't just the north that changed. Because so much of the planet's water was locked up in ice, sea levels dropped dramatically. At the peak of the last glacial maximum, global sea levels were somewhere around 400 feet lower than they are right now. That's not a small difference. That's the difference between coastlines we know and enormous stretches of land that don't exist anymore. The continental shelves that today sit underwater were exposed as dry, walkable terrain. The British Isles weren't islands. They were connected to mainland Europe by a wide plain that archaeologists now call Doggerland, a region of grasslands and river valleys and wetlands that was home to animals and humans both, before the ice melted and the sea came back to reclaim it. The same thing was happening all over the world. Southeast Asia looked completely different. The islands we now call Indonesia, Borneo, Sumatra, Java, they were all connected to the Asian mainland by exposed land that's now called Sundaland. Ancient humans walked across that landscape and spread into regions that are now separated by open ocean. Australia was reachable from the mainland without crossing nearly as much water as you'd need today. The geography of the world that early humans explored bears almost no resemblance to the maps we grew up with. Now, let's talk about what was actually living on that land, because the Pleistocene megafauna situation was something else entirely. When you picture ancient Africa, you probably picture something like modern Africa: lions, elephants, giraffes, zebras. And while that picture isn't completely wrong, it's missing a huge portion of what was actually there. Africa during the Pleistocene was home to species that no longer exist. Giant buffalo with horns spans wider than a car. Massive short-necked giraffes. Hippos that ranged all the way across North Africa, which was far wetter than it is today. Saber-toothed cats. Enormous hyenas that could crack elephant bone. Outside of Africa, the picture was even stranger. Europe had woolly mammoths, woolly rhinos, cave bears that stood taller than modern grizzlies, cave lions that were significantly larger than the lions alive today, and giant deer with antler spreads stretching up to 12 feet across. Asia had its own versions of these giants. North America, when humans arrived there somewhere between 15,000 and 20,000 years ago, was packed with megafauna that had never encountered a human hunter before. Mammoths, mastodons, giant ground sloths the size of elephants, short-faced bears that could run down prey on open ground, American horses, American camels, saber-toothed cats. It looked less like the continent we know and more like a version of Africa that had been rebuilt from scratch. South America had its own extraordinary cast of animals. Glyptodonts, which were armadillos the size of small cars with armored shells and clubbed tails. Giant ground sloths that weighed several tons. Terror birds, flightless predators standing over 6 feet tall that hunted across open grasslands. The world ancient humans moved through was not a quieter or simpler version of today's world. It was louder, more dangerous, and far more densely packed with large animals at every level of the food chain. What did the climate actually feel like on the ground? That's harder to pin down with a single answer because it varied enormously by region and by time period. During glacial peaks, temperatures in the higher latitudes dropped significantly. Central Europe wasn't a temperate forest. It was cold steppe. dry, windswept, and treeless for hundreds of miles, the kind of landscape that today you'd only find in parts of Siberia or northern Canada. Further south, the tropics stayed warmer, but the reduced moisture in the atmosphere meant that rainforests shrank and grasslands expanded. The Sahara, which is now one of the driest places on Earth, went through wet phases where lakes, rivers, and grasslands covered terrain that's now pure desert. Ancient humans were living around those lakes and leaving behind rock art that shows hippos and crocodiles in regions that haven't seen standing water in thousands of years. Then the climate would shift again. The interglacial periods, the warmer phases between ice ages, brought their own dramatic changes. The ice retreated, sea levels rose, coastlines moved, forests expanded back across regions that had been open steppe for thousands of years. The animals adapted or moved, and the humans followed. This wasn't a peaceful or gradual process for the people living through it. It was constant pressure. The landscape you hunted last year might be fundamentally different 2 generations from now. The coast your grandparents fished from might be miles inland by the time you're old. Ancient humans didn't experience climate change as a slow background trend. They experienced it as the permanent condition of their lives. What did they actually see when they looked around? If you were a modern person dropped into the landscape of Europe 30,000 years ago, the first thing that would hit you is the scale of the animal life. Mammoths in herds crossing open country, woolly rhinos moving in small groups through the brush, cave hyenas picking through carcasses on the edge of every campsite, bison in numbers that are difficult to even visualize, reindeer migrating through valleys and flows that stretched for miles. The humans who painted those animals on cave walls in southern France and northern Spain weren't doing it from memory or imagination. They were painting what they saw every day. The detail in those paintings, the musculature, the movement, the specific markings, that's the work of people who spent their lives watching these animals up close. And the plant life would be equally unfamiliar in many places. During cold phases, much of Europe north of the Alps was open grassland and tundra, no forests. Low shrubs, grasses, sedges, and wildflowers that bloomed briefly in the short growing season. The sky would have been enormous in that landscape, uninterrupted by tree lines. During warmer phases, forests came back. Birch first, then pine, then eventually the mixed temperate forests of oak and elm and hazel that modern Europeans are more familiar with. Walking through Europe 15,000 years ago versus 10,000 years ago would have felt like walking through completely different continents. Africa throughout much of this period was more stable in terms of temperature, but far less stable in terms of moisture. The Sahara cycled repeatedly between lush and barren. The Saharan pump, as researchers sometimes call it, was essentially a valve that opened and closed over thousands of years, either connecting sub-Saharan Africa to North Africa and the Middle East with habitable corridors, or cutting those corridors off with desert. When the pump was open, humans and animals could move freely northward. When it closed, populations were isolated. Those isolation events are written into human genetics today, in the patterns of genetic diversity that show where populations were separated from each other for long stretches of time. The vegetation of the tropics during the Pleistocene was more dynamic than it often gets credit for. Rainforests weren't the stable, eternal jungles of popular imagination. They expanded and contracted with each climate cycle, retreating into refugia during dry periods and expanding back out during wetter ones. The Congo Basin, the Amazon, Southeast Asian rainforests, all of them went through these contractions and expansions. The plants and animals inside them evolved in response to that pressure, which is part of why tropical biodiversity is so extraordinarily high today. All of that isolation and reconnection over millions of years drove speciation at a rate that more stable environments couldn't match. What about the oceans? The sea that ancient humans saw from a beach 20,000 years ago was not the same sea we see today. In addition to being lower, it was colder in many places, particularly in the higher latitudes. Ocean circulation patterns were different. The North Atlantic, which today keeps northwestern Europe far warmer than its latitude would otherwise allow, was disrupted during glacial periods by massive influxes of meltwater. The productive coastal zones where fish and shellfish concentrated were in different locations. The shallow continental shelves that are now underwater were exposed, meaning the coastlines where early humans gathered food and built camps are mostly gone now, drowned by rising seas at the end of the last ice age. This is one of the reasons the archaeological record for coastal human populations from the Pleistocene is so thin. We're not finding their sites because the sites are sitting under 300 to 400 feet of water on continental shelves around the world. The humans who lived along those ancient shorelines left almost no trace that we can currently reach, which means we're probably dramatically underestimating how much of early human life was tied to coastal environments. There are researchers who think the coastlines were highways, that early humans followed productive shorelines across enormous distances at a pace that inland routes couldn't match. The sky itself would have looked different in one very important way. No light pollution. Zero. On a clear night, the Milky Way would have been a solid band of light bright enough to cast faint shadows. The number of stars visible to the naked eye in a truly dark sky is something that almost nobody alive today has ever experienced. Ancient humans looked up at that sky every night of their lives. They tracked the stars. They noticed patterns. The same mental capacity that let them read animal behavior and understand seasonal cycles got applied to the sky, which is why astronomical knowledge shows up so early in the human record, embedded in cave art, in the orientation of structures, in oral traditions that encode star positions with enough precision to be useful for navigation. Fire changed what the night looked like too, in a very localized way. Once early humans had consistent control of fire, which stretches back several 100,000 years at least, campsites had a different character. The firelight created a small bright circle in an otherwise completely dark world. Everything beyond the edge of that light was invisible. What was living in that darkness, and what it thought of the light, is something we can only guess at. But cave lions and cave hyenas and bears were real threats at night, and the fire was doing real work keeping that darkness at a manageable distance. What were the rivers like? Bigger, in many cases. During wetter climate phases, river systems that are now modest or seasonal carried far more water. The rivers of North Africa flowed into the Sahara during humid periods, feeding lakes and wetlands in what is now complete desert. The Congo was larger. Rivers across the Middle East that are now seasonal trickles ran year-round during wetter phases and supported plant and animal communities that have long since disappeared. The Nile had a different character. The Jordan Valley was wetter. The landscapes that would eventually give rise to the first farming communities in the Fertile Crescent were shaped by river systems and rainfall patterns that no longer exist in the same form. Mountains shaped ancient human movement in ways that are still visible in population genetics today. The Alps were a serious barrier during glacial periods, effectively cutting off southern Europe from the north. The Himalayas funneled human movement into specific corridors on their eastern and western flanks. The Caucasus Mountains acted as a filter between the Middle East and the Eurasian steppe. Populations on either side of major mountain ranges were often genetically distinct, even when they weren't separated by enormous distances in straight-line terms, because the mountain terrain made direct contact difficult and sustained contact even harder. Volcanoes played a role that was anything but background. Around 74,000 years ago, a supervolcano on the island of Sumatra erupted in an event called the Toba eruption. It was one of the largest volcanic eruptions in the last several million years. The ash it ejected into the atmosphere blocked sunlight across a huge portion of the planet, causing a volcanic winter that may have lasted years and triggered a sharp drop in temperatures that lasted much longer. Some researchers have argued that this event drove human populations to a dramatic bottleneck, a near-extinction moment from which we recovered with reduced genetic diversity. The idea is still debated, but the eruption itself was real and its global reach was real, and any humans living downwind of Toba during those years were living through something genuinely catastrophic. The forests of the ancient world were also home to sounds we'll never hear again. The calls of megafauna that no longer exist. The sounds of bird species that went extinct when the large animals they depended on disappeared. The specific acoustic character of a mammoth steppe or a Pleistocene European woodland was unique, and it's completely gone. The silence that replaced the megafauna across most of the world after the Pleistocene extinctions was a real ecological change, not just a metaphor. The soundscape of the natural world today is quieter and less complex than the one ancient humans grew up inside. The extinctions themselves reshaped the landscape in ways that are still visible. Large herbivores are ecosystem engineers. Mammoths knocked down trees and opened up land. Giant ground sloths turned soil and spread seeds. Mastodons shaped forest structure through their browsing. When those animals disappeared, the ecosystems they'd been maintaining began to change. Some forests closed in. Some grasslands shrank. Some plant species lost the animals that had been dispersing their seeds for millions of years and began a slow decline. The world ancient humans inherited at the end of the Pleistocene was already a diminished version of the world their ancestors had explored during its height, partly because of climate and partly because of what humans themselves had done to the megafauna. By the time the last ice age ended and sea levels stabilized into something resembling the coastlines we know today, the world had been remade. The ice was gone from most of the mid-latitudes. The great grasslands of the northern continents were giving way to forest. The megafauna of North America, South America, Australia, and much of Eurasia were mostly extinct. The Sahara was briefly green again before beginning its most recent drying phase. And humans, having survived all of it, 100,000 years of shifting ice and rising seas and erupting volcanoes and vanishing prey animals, were beginning to do something that no previous version of Earth had ever seen: settling down, growing food on purpose, and building the first permanent places to live.